Alright, so it's going to be our next notes in algebra. They're called absolute value functions. And we're going to skip lesson 3.7 right up to 3.8. Don't forget also that you have a test tomorrow. And this will be our last notes in chapter 3. We'll take a mid-chapter test tomorrow, and then we'll start reviewing a little bit for the next things that came along, the next ideas, and then we'll take another short test with that, and then we'll add some of the things we did the mid-chapter test on. So here, we're talking about absolute values and their functions, and this function is a function that's related to this one where the function of x equals the absolute value of x. Okay, so these kind of functions will start at the vertex or the origin of the zero origin, right? It will be a V-shaped graph, and if we look at the domain of the x values, it will be all real numbers, and they can be x positive or negative. And then the range, which is the y, it can be all non-negative real numbers. And that's talking about this one now. Now we can change this, do things to it, and we could make them, some of the range to be negative y numbers, and we'll see that in a minute. That's kind of the absolute value function. If we were looking at that function, it would kind of look like a V shape like this, and we would see these points like here's 1, 1. So like if we said the function of x is 1, and then we plugged it into that function, it would be the absolute value of 1 is 1, so we'd have 1, 1. But if we also put negative 1 in there, the absolute value of negative 1 would also be 1, so we'd have this point over here. And if we did 2, for instance, so the function of x is the absolute value of x. Let's say we put 2 in here, and we said 2, the absolute value of 2 is 2, so then we would have 2 and 2 right here. But then we can also do negative 2 and put it in, and its value in the absolute value would be 2. So we'd have this one 2 and negative 2 over here, right? This graph isn't perfect, but it would be this V-shaped. Okay, but we might have something a little different. Here we might have one of these absolute value functions, and we might have the absolute value plus 2. Okay? So if you remember when we talked about these, what that really means. So if we have this function and we're adding 2 to it, then we should see that the function will go up 2. And we can figure that out just by graphing some numbers. And a good rule with these kind of functions, when we see this, the absolute value plus 2, is to get a couple negative x's, a 0, and then do a positive x as well. Okay, we could even do another positive x if we wanted to. So then if we just plug this in, right? So with this function, we'd then have to solve them, right? So then we have, if this function, so we have, if the function of g is negative 4, it'd be negative 4, the absolute value, which would be 4, plus 2, so that would be 6. Right? And then negative 2, we plug that in. Negative 2, the absolute value is 2, plus 2 would be 4. And then 0, it's a 0, it would be 2. And if we came to 2, it would be the same thing, it would be 4. And then if we did negative or positive 4, it would then be, let me just put it over here for the x and the y. We could then get, if it was 4, it would then be 6. Okay? So we can then graph all these, and put these points and see what it looks like. And we should see it comes up 2. So if we did x negative 4, 1, 2, 3, 4, and then it would be 6. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And then it would be 4, 1, 2, 3, 4. There we go, right there. And then we would do negative 2, 1, 2, and then it would be 4. So it would be 1, 2, 3, 4, right around there. And then the 0, where it starts, the origin will be 0 and 2. So 0 and 1, 2. And then we would do the other side, positive 2 and 4. So it would be right up about here. And then the next one would be 4, 1, 2, 3, 4, and then it'd be up 6. So somewhere around there. Then if we were going to draw these lines in, we would do that. And we would see the new one, it moved up 1, 2. Okay, so when we see something like that, an absolute value function, we know it moves up 2. So if we've seen a negative 2, we would then see if this was the origin, then this would go down 2. Okay? That makes sense, I hope. So that's one example. There's some other examples we're going to look at here, and then we'll be done. Here's some other variations that we can see. If you just had that absolute value function, you know, the f of x equals the absolute value of x. If we just had that, we would just have 1, 1, 2, 2, 3, 3, and then we'd go here, 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 and then we'd have this V-shaped graph, right? This would be the original graph we're working off of, and just draw it in there. The pen didn't work that time. So this would be our normal graph that we would have if the function of x is the absolute value of x. Draw a little bit more on there. That's the starter. And then we might see, so we have here though, instead of just being the absolute value of x, the function of x is the absolute value, we have the function of g is x minus 4. And this we should see that in the end we get a movement of 4. If it's negative, we should be going this way, right? This whole thing. So with this one, we want to get, we know it's going to be, we want to start with 0 on this one. It just makes sense to do that and give us some points, and then we can figure out where the graph would be. And if we realize that the vertex of this one is 0, and negative 4 tells us to add 4, we should see the vertex move over to the 4. So 1, 2, 3, 4. We should see that be 4. Okay. And then that allows us to realize that we want to do a couple points on the other side of that vertex, and a couple points on the left side, and then a couple points on the right. Let's just figure out what they would be. So if x was 0, so the absolute value of x was 0, 0 minus 4 is negative 4, but then the value would be 4. 0, 4. That makes sense, right? Perfect. 0, 4, that'd be our vertex. And then we would have 2, and we plug that in. 2 minus 4 is negative 2, and then it would be 2. So we put 1, 2, and then we go up 2. It would be right here, the new point. We'll just go right over that thicker. And then we would have 4, so then we would have 4, plug that in. 4 minus 4 is 0, so 4, 0. So we'd have 1, 2, 3, 4 is 0, but I think I did this one wrong here. 0, that'd be negative 4, right? I got that one wrong. So go back. This is that one. So it should be negative, wait, it should be 4. Sorry. So this should be 0, 4. So we go 0, and it should be 1, 2, 3, 4. I wonder why I was starting at 0. But so there's that one side of it, and we know we're going to move right 4 because it's negative 4. To remember that. But we're going to move 4 right. We got this part, and then now we start to go up. So 6 minus 4 is 2. The absolute value of that is 2. And then 8 minus 4 is 4, and the absolute value of 4 is 4. So then we go 6. It's 4, 5, 6. And then we're going to go up 2. 1, 2. There's that one. And then we have 8, 4. And then we go up 2 more. Right there. And then if we just drew this in, we would see our new one is move 4 points or 4 places to the right. Because of this, we can kind of read that if we remember translations and how they all work. So this is our new one. This is the original f. The function of x equals the absolute value of x. If we move it, if we go negative 4, just remember that negative means actually to the right. And we have this new graph. And one more condition we have to worry about. And this is actually going to combine a couple. So here we have this, you know, the function of x. And if we put that in, let me just do that real quick. So we hear that where we have that function where the function of x is the absolute value of x. That's right here. That's that original one we always start with. This one's a little bit more stunted here than I drew in the top. But we have that graph here, but here we have a little bit of a difference. So we don't have something going on inside the x, the absolute value, but it's something on the outside. If you remember what that does, that kind of like dilates it, makes it like closer together. But also we have a negative number here, and what that should do is actually reflect it. So we realize that we're going to have the same vertex, right? It's going to just, so if it's going to reflect in the opposite direction, that'll help us decide which points to figure out. And we know the vertex, this thing should actually flip on the other side. And we'll see if it does that in a minute. So we would want to choose 0 as our middle point, and then pick a couple negatives and a couple positives, and then that could help us put some good points in there. So if we start with -4. So -4, the absolute value of -4 is 4, and then 4 times -2 is -8. That's our first point. Then -2, so the absolute value of -2 is 2, then 2 times -2 is -4. Then 0, plug it in there. 0 times -2 is going to be 0. They're both 0. And then 2 is going to be 2. The absolute value of 2 is 2. Then times -2 is going to be -4. And we'd see if we did 4, we'd get the same. The 2's and the 4's are going to be the same because we're just multiplying by a negative. So then we just need to put these points in. So we have 0, 0, right? And then we put -4, 1, 2, 3, 4, and -8, 1, 2, 3, 4, 5, 6, 7, 8. About there. And then we have -2, 4. So 1, 2, 1, 2, 3, 4. And then we have 0, 0. That looks good. And then we have 2, 1, 2, and -4. It's going to take us down to right about there. And then 4, -8. It's going to take us down to about right there. And then we just connect these with lines, and you get this new graph right here. So this one is the g of x equals -2 times the absolute value of x. So you see what happened? These kind of got squeezed a little bit together. That's the 2. And then the negative gives us the reflection. It was on the top, and then it just flips over to the bottom. So that's like, I just gave you like 3 examples of these. Make sure you add these to your notes, and then we'll go over some examples in class if you're ready. Or if you have questions on here, make sure you post them on the YouTube page or the YouTube video, and I'll try to answer them for class. And see you guys in class tomorrow.